discuss the relations, okay, then domain and range of a relation. Now let's come to the very important topic, which is called the functions, okay. And functions is regarded as the heart of the calculus, okay. Now let's see the definition. Let A and B be two non-empty sets, then a relation F which associates each element of A with a unique element of B is called a function from A to B. That means in a function there are two things which are very important. One thing is each element of B, each element of A. That is, there is no element in A which is not related to the element in the set B. It means each and every element has been related to some other element in the set B. And next thing, with a unique element, this is also important. The relation is very unique. That means if an element, let's suppose X, is related to the element Y in the set B, the element X cannot be related to some other element in the set B. This is what we meant by the unique. Okay. So now what is image? Let's suppose we have a set A. So in the set A we have X as our element, and in the set B we have Y as our element. Let's suppose X is related to Y. Then I can say this X is related to Y. Then I can say this Y is the image of X under the function F, and then this X is called the pre-image of the Y. You can see here definition. If F associates X belonging to A to Y belonging to B, it means when X is related to Y, then Y is called the image of the element X under the function F. And similarly, the element X is called the pre-image. This element X is called the pre-image of the Y. Now domain, what is a domain? The whole set A is your domain, okay. And what is your codomain? The whole set B is your codomain. Now what is the range? The range is the set of all images. These are the images. If you make a set of all those images, okay, if you make a set of all those images under the given function, that set will become your range, okay. So I have written a definition here. Range is the set of all images of the elements in A, okay. So whichever elements in the set A are present, the image of those elements, okay, the image of those elements which are present in the set B, if you make a set of those images, you will it will become range. So range of actually it is a F. Range of function is given by f of x. By f of x it means range of f is set of all images. This is called the image. This is called the image. And if you take the set of all images where this x belonging to set A, that means this x should be in the set A. So this is all about the functions. Let's see them with the help of some examples. Okay. I will take some examples which will clear you that which is a function and when can you say this is not a function. Okay. Okay, let's take some examples. Let's suppose I have this function. This is my set A. This is my set B. Let's suppose I have another. Okay. Now let's suppose this is my function f1 and this is also set A. This is also set B. So this is my function f2 and this is set A, set B, set A, set B. And this is my function f3. I'm writing it name. I'm not sure is it is a function or not. So let's write the elements. Okay, let's suppose 1 is related to the 7 and 3 is related to the 6, 4 is related to the 8 and 2 is related to the 9. Okay, then we have okay. Now in this, let's suppose 1 is related to 7, 2 is related to 8, 5 is related to 9, 3 is related to 10, and 3 is also related to 12, and 4 is related to 11, and 6 is related to 8. Okay. Now let's suppose here we have another function 1, 2, 3, 4, 5, 8, 9. Let's suppose 10, 11, 12, 13, 14. Now let's suppose 1 is related to 11, 1 is related to 13, 2 is related to 12, 4 is related to 14, and 3 is related to 10, and 5 is related to 12, 8 is related to 13, and 9 is related to 14. Okay, let's suppose I have another relation 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12. Okay, let's keep it. Okay, no worries. So 1, 8. Let's suppose this is, so 2, 10, 4, 12, 3, 11, and we can have 5. Let's suppose 5, 11. Okay. Now you need to remember only two things when you are discussing the functions. One is each and every element of set A should have image. So first, and the second thing is the image should be unique. There should not be two images to a single element. So let us check one by one. Here, first of all, we'll check for the first condition. Does each element of A has image or not? Since here 5 has no image, therefore it cannot be a function. It's not a function. It's very simple. Keep it very simple. These are the two rules which will give you a hint about whether a relation, the given relation is a function or not. Okay, let's check for the F2. Here 1 is related to 7. Okay. First of all the elements have some image. They are related to somehow to the to the elements in the set B. Now 1 is related to 7, 2 is related to 8, and 3 is related to 10, and 3 is also related to 12. It means 3 has got two images. This means it is not a function. This means it is not a function. Now what about the F3? 1 has got two images, 11 as well as 13. It's not a function. Okay, now what about this? 1 is related to 8. Okay, this is I have just mentioned here a function. Now 2 is related to 10, 3 is related to 11, 4 is related to 12. There is no point. Okay, so now 6 is related to 8, but does 1 has two images? No, it has got only one image. 1 has got 8 images. But has got an image, that is 8, and 6 has got a same image, that is 8. So it means there each and every, and you can see 5 has got image 11. You can see here each and every element of A has got some image, and that image is unique. But yes, there are some images which are common to the both elements. Let's suppose 8 is the image of 1 as well as 8 is the image of 6. So it is a function. There is no problem in this. So it is a function. Okay, let's give another example. Let's suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's suppose my set A and this is set B. Relation is F5. 1 is related to 6, 2 is 7, 3 to 8, 4 to 9, 5 to 10. Is this a function? Yes, it is a function. Why? Because each and every element of A is related to the set B uniquely. So there is unique image of each and every element of the A. So therefore, F5 is a function. You may ask one question, sir. There is some pattern which is missing in this F5. Which pattern? So the last element B has got unrelated. It's not related to anything. My dear, I said only that there are two conditions. for a relation to be a function. Okay, first condition is each and every element of A should have an image, and that image, second condition, that image should be unique. You can see here it is a function because each and every element of A has its image unique. And yes, there can be two different elements can have same image. That's something else, that is secondary thing. But I'm saying each and every element of A has unique image. That means one cannot have two images. One has only one image. 2 has only one image, 3 has got only one image, 4 has got only one image, 5 has got only one image, 6 has got only one image. So this is the concept of functions. In the next lecture, we'll see how to calculate the domain and the range of the function. Okay, so you can clearly see here this set A whole is your domain. Here set B whole is your codomain, and range is 6, 7, 8, 9, 10. I said range is a set of all images. So range will be 6, 7, 8, 9, 10. Okay. So here it is a function. So here also domain will be all set A, and here codomain will be whole set B. And here you will see that range is also your codomain. So it means range is sometimes subset of codomain, or it is sometimes equal to codomain. Okay, so this is all about functions. Thank you so much. Now I want to discuss here features of functions from set A to set B. Now, first one is for every x belonging to A, there exists is y belongs to B such that y is equal to f of x. That is, each element of A has image in B. See, in the previous lecture, I also discussed this thing, that I told you there are two conditions that needs to be satisfied for a relation to become a function. First and the foremost condition is that each element in the set A should have some image in the set B. In other words, each and every element of set A should be related to some element in the set B. Okay, but there is a precaution, but there may be some elements in the set B which is not the image of any element of A. See, in the set B, there may be some elements which are not associated to the set A. So it can happen. Okay. Now the next thing, the next important thing, I told you that it is the relation should be unique. That is, each element in the set A should be also uniquely related. That is, one element in the set A should not have two images. It should not be related to two elements at the same time. Okay, so it means the image of each element of A should be unique. But see, there may be some different elements of A which has got same image, which is related to same element in the set B. That can happen. Okay. The next thing is, if the graph, this is very important. So this is very, very important, that if you, let's suppose a graph of the function, a graph of the relation is given in the question, and you are asked to check whether the given graph is a function or not. So the basic step is that if you find a line parallel to y-axis, if you find any line parallel to y-axis which cuts the given graph at more than one point, then it does not represent the graph of the function. Okay, the graph of function is like it should anywhere. If a line is drawn anywhere parallel to the y-axis, it should cut at only one point. It should cut the graph at only one point. Then and only we can say this: the graph is the given graph is the graph of the function. Let us see with these things with an example. So let us write an example. We have A is equal to 1, -1, -3, -3. and we have b is equal to 1, 4, 9, 10, 11. 1, 4, 9, 10 and 11. Okay. Now let's suppose our function is nothing but x square. If I write this function in the roster form, I will get 1, 1. 1 का स्क्वायर आएगा 1 ही, -1 का स्क्वायर भी 1, तो इसका मतलब -1, 1. उसके बाद 2 स्क्वायर आएगा 4, 2, 4. Then I will get 3, 9. Then I will get -3, 9. Now if I write this function in the arrow diagram representation, it will look like this. So in the A set I have 1, -1, 2, 3 and -3, and in this set we have 1, 4, 9, 10 and 11, and it is a function f from a to b. 1 is related to 1, -1 is also related to 1, 2 is related to 4, 3 is related to 9, -3 is related to 9. Now let us check the two conditions that I discussed with you earlier. That the first and foremost condition should that each and every element of A should have some image in B. It's clear from the arrow diagram representation that each and every element of A is related to the elements of set B. Now the second rule is that this relation should be unique. That is, each element of A should be uniquely related to the element in the set B. So that means it should not have more than two images. It should have only one image. Okay, so 1 is related to 1 only, -1 is related to 1 only, it has got only one image. 2 has got only one image, that's 4. 3 has got only one image, 9. -3 has got only one image, 9. But see, there are -1 and -1. These are two elements which have got same image, 1. Okay, 3 and -3 have got same image, that is 9. So this satisfies the condition to be a function. Okay, let us see this function with the help of a graph. So if I draw a graph of this function f of x is equal to x square, it will look like this. Okay, and if I draw a line parallel to y-axis at any point, let's suppose here, you want to draw at any point, it intersects the graph at only one point. Hence, it satisfies the condition for being a function. Okay, so this is all about. I want to discuss about the domain of function. We'll see here different types of questions, and we'll try to find the domain of a function. And after this lecture, you'll be able to solve any question, any function for its domain. Okay, now we have two rules for finding the domain. Okay, these are very simple rules. Okay, one rule is that if you have expression under even root, if you have an even root, what do we mean by even root? That is second power, square root, fourth power of root, sixth power of root, that's even roots, eighth power of root. Okay, so these expression which is under that even root, that should be greater or equal to 0. Why? In order that the function is defined, in order that the function is real, we need that the expression under the even root should be greater or equal to 0. Like if we see an example, this example 1, if we have a function f of x is equal to under root of x square minus 4x plus 2. Here, in order that this function is defined, this x square minus 4x plus 2 should be greater or equal to 0. Okay. Now, second rule is that denominator of a function cannot be equal to 0, because if denominator is equal to 0, the function becomes not defined. Okay, as you can see, if I have a function x square minus 4x plus 2 divided by x square minus 3, this x square minus 3 cannot be equal to 0. Well, it should not be equal to 0. Why? Because if it is 0, then the function becomes not defined. Now let us discuss some questions. So first of all, I will discuss a question. So question is, find the domain of the function f of x is equal to under root of x square minus 25x plus 144. Okay. Okay. Now solution. Okay. You will follow these steps in each and every question. Okay. Now this is a expression. This is the expression under the square root, and I discussed the rule that this expression should be greater or equal to 0. That means this x square minus 25x plus 144 should be greater or equal to 0. It should be greater or equal to 0. It can't be less than 0. Let us see when it is equal to 0. Then what happens is that x square minus 25x plus 144, it is equal to 0. Let us find the roots, and you will solve. When you will solve this, you will find two roots, x minus 9 and x minus 16. Okay, there are two factors to this equation. So one is x minus 9 and one is x minus 16. Next, so this gives me x is equal to 9 and this gives me x is equal to 16. Another step is to plot these 2 points on a number line. So this is my 9. So here I will get my 16. So this is the minus infinity point. This is the plus infinity point. Okay. So I am getting 3 regions. My number line is divided into 3 regions. This is one and this is another. This is another. Now let us check the signs. Okay, let us check the signs of this function. You know this negative sign is not valid. Why? Because it should be greater or equal to 0. It means it should be positive. And where the positive, this function is positive, this expression is positive, we'll write here positive. Okay, let us check in between these two. Let's check for 9 and 16 in between of the two. So in between of the two, let's suppose I will take 10. Okay, let us suppose I am putting 10 in this. So I will get 10 square minus 25 into 10 plus 144. And I will get 100 minus 250 plus 144. And I will get minus 150 plus, I suppose I will get minus 150 plus 144, and I will get minus 6, which is less than 0. That is, it is negative. It means in this region I have a negative sign. Okay, let us check for the 9. Can I take 9 as the domain? Let us check it. When I put x is equal to 9, it is obvious that when I put x is equal to 9, I will get the value here 0, which is valid. It means I can take the x is equal to 9. Can I take x is equal to 16? Yes, because when I put x is equal to 16, this is becomes 0, so therefore I can take. Now let us check for these 2 points. Let us suppose I will take x is equal to 0. So at x is equal to 0, what will I get? 0 square minus 25 into 0 plus 144 is greater or equal to 0. Sorry, I will get 144, which is greater than 0. It means here the sign is positive. Now 16, अगर मैं 16 से ज्यादा कोई नंबर लूंगा, लेट सपोज आपको कोई भी नंबर आप लोगे ना, लेट सपोज अगर आप लोगे x is equal to, let's suppose 17. Okay, and you will find this will be greater than 0. It will be positive. So I will get positive here. So what will be my domain? Domain can be anything. It can be anything, but it cannot be between 9 and 16. It can be from minus infinity to 9 and 16 to infinity. But it cannot be between the 9 and 16. Why? Because if you put x is equal to 9 to 16 in between, then you will get negative value of this function, which is not valid. Okay, so we will get the domain then. First of all, minus infinity to 9, but 9 is included, so I write it. Next, I union it with 16 to infinity. So this is the domain of the given function. Now there is a second question. I am erasing it. Okay. Now next question is that under root of x square minus 5x plus 6. X square minus 5x plus 6. Okay, I know for this function to be defined, so my x square minus 5x plus 6 should be greater or equal to 0. Okay. Then I will find the roots of this equation. I will get x square minus 3x, and when I will write when x square minus 5x plus 6 is equal to 0. Now I will find the roots of this equation similar to the question number 1 which I taught you. So I will get x square minus 3x minus 2x plus 6 is equal to 0. Then I will get x into x minus 3 minus 2 into x minus 3 is equal to 0. And I will get x minus 2 into x minus 3 is equal to 0. Next I plot these 2 points on the number line. Therefore I will create three regions in the number line. This is plus infinity, this is minus infinity. Now is 2 and 3, can I take them? Yes, I can take them, because when I take x is equal to 2 and x is equal to 3, this expression becomes 0, which is valid. So let us find in between. In between is 2.5. So let's suppose I will take 2.5, that is 5 by 2. So x square, and I will get at x is equal to 5 by 2 is actually your 2.5. So I will get 5 by 2 square minus 5 into 5 by 2 plus 6 is equal to 0. Now it will be 25 by 4 minus 25 divided by 2 plus 6. You don't have to put it 0, we have to check it. So we will take the LCM 4, that is 25 minus 4 divided by 2 is 2, 20, it is 50 plus it will be 24, and it will come out to be minus 25 plus 24 divided by 4. It will come out to be minus 1 by 4, which is negative. So it means in the between region it is negative. And when you put x is equal to 0, and you will find this will be positive. So this will be positive. Again, if you find x is equal to greater than 3, you will also find it positive. Therefore the domain will be minus infinity to 2 union 3 to infinity. Okay. Now let's do another question. I have a question. F of x is equal to x square minus 4 divided by x minus 2. X square minus 4 divided by x minus 2. Okay, we have to find the domain. So its solution is easy. Why? Because for f of x to be defined, I told you that denominator should not be equal to 0. It means x minus 2 should not be equal to 0. What does this mean? X should not be equal to 2. It means domain actually is nothing but the possible values of x. It means domain is all values of x. That means all real values, but without this 2 value. Okay. Next, I will discuss another question. It is you have a function f of x is equal to 1 by 1 minus x square, and you have to find the domain. And for f of x to be defined, 1 minus x square is also should not be equal to 0. Let us see if it is equal to 0. When 1 minus x square is equal to 0, then implies x square is equal to 1. It means x is equal to plus minus 1. It means that whenever you put x is equal to 1, it will become 0, and whenever you put x is equal to minus 1, it will become 0. Therefore x has any value but without these two. Therefore domain is nothing but r minus 1 comma 1. Okay. Next, let's suppose I have another question. F of x is equal to under root of x minus 1. So for this function to be defined, x minus 1 should be greater than 0. It means x should be greater than 1. If I interchange this, if I transpose this minus 1 to the left hand side, I will get x is greater than 1. It means x should not be equal to 1. X should be greater than 1. This is the domain. So it means domain is nothing but 1 to infinity excluding 1. Okay. Then we have another question. Let us erase the board first. We have another question. F of x is equal to under root of 3x minus 5. So it is very simple. So for f of x to be defined, 3x minus 5 should be greater or equal to 0. Sorry, yes, it means 3x should be greater or equal to 5. That means x should be greater or equal to 5 by 3. What does this mean? This means domain is nothing but with included bracket 5 by 3 comma infinity, because it is greater than 5 by 3. It goes on infinity. So another question I will discuss here is, we have a question. F of x is given that 5 divided by x minus 3. So for this function to be defined, x minus 3 should not be equal to 0. That means x should not be equal to 3. So therefore domain is all real numbers but without this 3 number. Okay. Next I will discuss the function f of x is equal to x square minus 36 divided by x plus 6. For f of x to be defined, x plus 6 should not be equal to 0. That means x should not be equal to minus 6. It means domain can be anything. Domain can be all real numbers but without this minus 6. Okay. Now this is important question now. There is a question. F of x is equal to under root of x square minus 25. So for this function to be defined, clearly x square minus 25 should be greater or equal to 0. Okay, and when it is equal to 0, then x square is equal to 25, which means x is equal to plus minus 5. Next, I told you that we will draw these 2 points on the number line. So I will get 3 regions. These are the 3 regions. Let us check them one by one. Let us check for their signs. When we put plus minus 5, it becomes 0. That means we have to take these points. Now what about the 0? When we put x is equal to 0, 0 square minus 25, it will become negative. It means it is negative. And when you put minus 5 less than minus 5, that means minus 6. So minus 6 square is 36. 36 minus 25 is positive. It means it is positive. When I put greater than 5, 6 square is 36 minus 25 is positive. What does this mean? It means domain is nothing but minus infinity to minus 5 with close brackets union 5 to infinity. Okay, let us solve another question. I have a question. F of x is equal to under root of a square minus x square, where a is greater than 0. Okay, you have to find the domain. So for this function to be defined, a square minus x square should be greater or equal to 0. When a square minus x square is equal to 0, what will be the roots? X square will be equal to a square, and I will get x is equal to plus minus a, and then I plot it on the number line. Since a is greater than 0, it means a will be greater than minus a. So it's very important. Since a is greater than 0, then a will be greater than minus 1. That's why I am putting minus a on the left hand side and a on the right hand side. Okay, now there are 3 regions. This is 1 region, this is 2 regions, second, and this is 3rd region. Now let's check for all of them. Let's check for 0. 0 is in between this region. So when x is equal to 0, I will get a square minus 0 is equal to 0. That it is positive. Then it is positive. And when I get less than a, less than minus a, let's suppose less than minus a, I will take x is equal to minus 2a, which is less than minus a. So I will get a square minus x is equal to minus 2a square. That is equal to a square minus is plus 2 to the 4a square, and it comes out to be minus 3 square, which is negative. And if you calculate at x is equal to 2a, which is lies in the region this, it also become negative. So domain is nothing but you have to take these 2 points. Why? Because these 2 points will give you the 0 value, and that is valid. So we will take from minus a to a. Now there is a question similar to this question. It is given that f of x is equal to under root of 64 minus x square. You have to find the domain. You can use the result of this. So f of x is equal to, I can write it as 8 square minus x square. Here, since 8 is greater than 0, 8 is greater than 0, this a is greater than 0, 8 is greater than 0. So I can similarly, using the result to this, I can find the domain here, minus 8 to 8. Okay, it's very simple. Now, next question. The question is f of x is equal to x divided by, this is very important question, x divided by under root of x square minus 3x plus 2. Very, very important question. This is important. Actually, the two rules are mingled in this one question. Okay. Now, for f of x to be defined, this x square minus 3x, first of all, two things will happen. This x square minus 3x plus 2 should be greater or equal to 0. But then if x square minus 3x plus 2 will be equal to 0, the denominator becomes 0. That means when denominator becomes 0, it will become not defined. Therefore, we cannot take equal to. Getting me? So I am left with only one possibility, that this expression should be greater than 0. And when it is greater than 0, what will I get? Let's find the roots of this equation. X square minus 3x plus 2 is equal to 0. I will get x square minus 2x minus x plus 2 is equal to 0. And I will get x into x minus 2 minus 1 into x minus 2 is equal to 0. And I will get x minus 2 into x minus 1 is equal to 0. And then I will plot, which implies x is equal to 2, 1. So I'll plot 1 here and 2 here. So I will get 3 regions. This is one region, second region, and so this is minus infinity to infinity. Now in this region, let's find what is the result. See, when you take x is equal to x is equal to 1 and x is equal to 2, you will get a result 0, which is not valid. So therefore, these two possibilities are overruled there. The x cannot take value 1 and 2. Let's check for less than 1. Let's suppose 0. When x is equal to 0, 0 square minus 3 into 0 is 0. So 2, which is greater than 0. Yes, it is positive. Now let's check in between. Let's suppose I am getting 1 by 2. 1 by 2 lies, 3 by 2. 3 by 2 is 1 by 1.5. So let's suppose at x is equal to 3 by 2. What will I get? X square, that is 3 by 2 square minus 3 into 3 by 2 plus 2. And it comes out to be 9 by 4 minus 9 by 2 plus 2. And it comes out to be 4. 9 minus 18 plus 4 to the 8. And it comes out to be minus 1 by 4, which is nothing but negative. Therefore, it comes out to be negative. And if you find for greater than 2, it will come out to be positive. Therefore, domain is nothing there but from minus infinity to 1. But in excluding 1. Union 2 excluding infinity. So this is the domain of the given function. Okay. Now, last question. I will discuss the last question. There is a question, f of x is equal to x square plus 5x plus 1 divided by x square minus 6x plus 8. It's very simple. For this function to be defined, the denominator should not be equal to 0. That means x square minus 6x plus 8 should not be equal to 0. If it is 0, let's suppose when x square minus 6x plus 8 is equal to 0, let's find the roots. It will become x square minus 4x minus 2x plus 8 is equal to 0. And I will get x into x minus 4 minus 2 into x minus 4 is equal to 0. And I will get x minus 4 into x minus 2 is equal to 0, which implies I will get x is equal to 4, 2. So it means x can take any value but without 4 comma 2, because it makes the denominator 0. Therefore domain will be simply set of all real numbers but without 2 comma 4. So this was all about the domain, how to calculate the domain of different functions. Okay, if you like the video, please like it and share the video, and don't forget to subscribe the channel. Thank you so much.